Good morning again. This is Miss Parks, and today we're going to be talking about trig values, but we're going to be using our calculator to find them instead of using the normal numbers that we have been recently talking about, which are the 30, the 45, and the 60-degree like reference angles. We're going to be finding other angles around the circle, and we're going to be using decimals, and it's an introduction of how to use your calculator to do this. So the first thing is that your calculator can be in three different modes. It can be in radian, gradient, and degree mode. Degree is the most common, and this is the one where I would like you guys to be in degree mode. So if this is your calculator, and then you're up in this little part of your calculator, there should be a D or a DEG up there to indicate that you're in degree mode for most calculators. If you look for a button that looks like this, DRG, it's somewhere around here usually. It'll toggle between them, and for most of you, the calculator will automatically be in degree mode by default. Now, if you want to check to see, you can put sine of 30 in your calculator. So if you put sine of 30 in your calculator, it will give you 1/2 or 0.5, because a lot of calculators will just give you decimals. And then if it does, that means that you're in the correct mode. If not, you might have to read your manual to try to flip between degree, radians, and gradient mode. It needs to be in degree mode. All right, so in order to do these, for anything that's in minutes and seconds or degrees and minutes, we're gonna divide this by 60 first, this part. So this is going to give us sine of 49.2 degrees. And then you're just going to put it in your calculator. For most calculators, you just put it in exactly like that. And then we're going to go to 3 numbers after the decimal for these. And you should get 0.757. And that's not degrees. This part is degrees. It's telling the calculator that you're going to put sine in degrees, not in radians. For the second part, you're going to do secant. Your calculator does not have a secant button on it. And so this is considered one term, one thing. You can't separate those from one another. But we do know that we can use cosine on our calculator, and secant and cosine are reciprocals. So secant of 97.977 is exactly the same as 1 over cosine of 97.977. Okay, because cosine is the reciprocal of secant. When you put this into your calculator, you're going to be putting 1 divided by cosine of 97.977. It is degrees. You don't have to put the degree sign in your calculator. For some calculators, you have to put 1 divided by 97.977 cosine. Some calculators work backwards, and so you have to put the degree before the cosine. Just play around with it. I'm going to give you the answer, and then hopefully you can figure out what order to put the numbers in. Go ahead and do the rest of these 8, and then I will put the answers up there and show you how to do them. Again, the only thing you can do on your calculator is sine, cosine, and tangent. So if it's not sine, cosine, or tangent, you will have to use the reciprocal of whatever is already there. Okay, so since we can't put cotangent in our calculator, the reciprocal of 1 over cotangent is tangent of 51.4283, and that is 1.254. Sine of negative 246, just put it in exactly like that. You might have to use parentheses, you might not, depends on your calculator. For most calculators, I don't think you'll have to use parentheses to do that. You should have 0.914. For tangent of 68, you can just put that in exactly like it is. Cosine, you can put that in exactly like you read it, negative 9.7, excuse me, 0.972. For sine and cosine, your answer will never be bigger than 1. Okay, sine and cosine, you're never going to answer bigger than 1. For cosecant, we don't have that in our calculator, but cosecant is the reciprocal of sine. And yes, I would like you guys to write this step. And then that will equal 1.708. Whenever you have an equal sign, this to me just shows that this is equal to what was previous to it. When you do your final answer, you don't need to circle the equal sign like equals 1.708 unless you have something on the right and the left of that. Okay, this is kind of just like a continuation of what's before it. And then for secant, secant is a reciprocal of cosine. The reason they use parentheses is so it doesn't look like secant minus this. It's secant of negative. All right, so we put that in the calculator, and you should get 3.420. Now, you may have remembered when I said cosine will never be bigger than 1, and neither will sine. This is not cosine. It's actually secant that we're answering. We just have to put 1 over cosine to get the secant answer. All right, so for the next ones, we're actually going to find, they're giving us this answer, and we're going to find the angle that it came from. So sine theta is equal to 0.967. So when we did these questions up here, I see that sine of negative 246 is this answer. This is kind of close, but not really. But we're going to actually find the angle that it came from. So in order to find angles, this is when you're going to be using inverse. And inverse is the button that is right above sine, cosine, and tangent. So this is inverse sine, inverse cosine, and inverse tangent. It's not like sine to the -1. This is when you read it as inverse sine, and you only use it to find angles. And that's it. You don't ever use it for anything else. So sine theta, the only way to get sine and theta away from each other, it's like saying 2 times x, the opposite of multiplying by 2 would be dividing by 2. If you had x plus 2, the opposite of adding 2 is subtracting 2. If you had x squared, the opposite of squaring something is square rooting it. So sine theta, the only way to undo this is to do the inverse sine. So we're going to do the inverse sine of both sides. So inverse sine and sine, they cancel each other out, and you're left with theta. Here, you do inverse sine of 0.967, and you will get an answer which is a degree. Now, if you want to check to see if you got that right, just do sine of this angle, and it should give you something close to this. We rounded, but you can go ahead and round to the tens place here. Remember here it says to give an answer between 0 and 90. Okay? For this one, we don't have secant in our calculator. So in this case, we will have to take the reciprocal of both sides. So the reciprocal of secant is cosine theta. The reciprocal of this is 1 over 1.054. Now, normally we don't put decimals inside of fractions, but it's, remember when we were doing sine, cosine, tangent. So if I gave you sine theta is 1/3, then cosecant theta was 3 over 1. If cosine theta was 2/5, secant theta was 5/2. So that's what this is. Just so happens that that's a decimal. So we're taking the secant answer and flipping it over to get the cosine answer. Now we still have to solve this. So this is inverse cosine of this side. And the inverse cosine goes in front. I know a lot of you would probably put it in the back because that's where there's room. I don't like to do that. So this is theta. And then the inverse cosine, you have to use parentheses or you will not get the right answer. So inverse cosine of parentheses. Don't use the fraction bar in your calculator. A lot of you will get an error if you try to use a fraction bar with a decimal. So just use a parenthesis and then a 1 divided by 1.054, close parenthesis, when you're putting this in your calculator, and then you do inverse cosine first. For some of you, you'll be doing inverse cosine afterwards, depends on your calculator. You should get 18.4 degrees. And then For the last one, go ahead and do this one. All right, so we have inverse cosine on both sides. So we get, and don't just put -1 there, it's inverse cosine, okay? I do not want you to just put a -1 attached to that. Okay, theta is equal to 22.9 degrees. And yes, we need to put a degree sign. And that's your answer. Okay, for example 3, we're going to be finding grade resistance. So when a car travels uphill or downhill, there's a force due to gravity, okay? So that force due to gravity, they measure that in pounds, and it's called grade resistance, okay? So, and it gives you this equation. So that force, that grade resistance, is equal to the weight of the car times sine theta. Theta is the angle or the hill in a horizontal line, okay? So that's the angle of the hill, and that's theta that we're going to be using. So if it's going up, there'll be a positive force, a positive weight. And then if it's going downhill, there'll be a negative force. And this is, again, positive if it's going uphill, and then negative if it's going downhill, like how much force is put by gravity, okay? All right, so we're gonna have 3 problems. Force is equal to the weight times sine theta. There are 3 terms, and sometimes it looks like 4 here. For number 2, same thing. Force is equal to weight times sine theta. And for number 3, force is equal to weight times sine theta. So for number 1, it says calculate the force, or really we're calculating the grade resistance. Okay, F stands for the force in pounds, but it's actually the grade resistance. So the grade resistance or the force is what they want us to find, is equal to the weight of the car. Okay, the weight of the car is 2,500 pounds. Everything is in pounds except for theta. Theta is a degree in this formula. And then theta is 2.5. A lot of people just put 2.5 here and they get the wrong answer. Be careful there. It's sine of 2.5, which is a very small number. So when you multiply this out, you get 109.048. This says round to the nearest 10 pounds. Okay, so you're either going to be putting 100, 110, 120, 130, 140. So if you're rounding this 109 and the nearest 10 pounds is, this is 110, and then the one before that is 100 if you're going every 10 pounds. Obviously you need to round to 110. Okay, and LB is pounds. You need to leave a space so it doesn't look like that's a 1. Okay, go ahead and do the second one. Well, actually, I'll do the second one. The weight, because we have 3 more under here, is 5,000 times sine of negative 6.1. So this one is going downhill. So the force here is negative 531 pounds, which if we round to the nearest 10, we'll get negative 530 pounds. And again, please leave a space before the units of pounds so it doesn't look like a 1 here. All right, for the last one, it says calculate the force or the grade resistance when theta is 0. So when theta is 0, that means that there is no hill. Okay, there's no hill at all. And if there's no hill at all, then there's no force coming down the hill or up, or either way, actually, I should say. So there's no force because there's no hill. Okay, so here it's going uphill. And so gravity's pulling it down a little bit, but because the car is traveling uphill, it's just going to be pulling it down at 110 pounds. Here, that 6.1, the truck is going downhill, and so the gravity and the truck are providing more force. But if there is no hill, then that truck, if it wasn't moving, or the car, wouldn't have any force being pulled on it in any direction. Like, it's not going to be pulling it this way or this way because gravity pulls downhill. Okay, so in this case, you could do the math, but for the zero, okay, there's two questions actually. So for the zero, okay, so when theta equals 0, that means that there's no hill and F would equal 0 pounds. Now, what is 90 degrees? So 90 degrees would be straight up and down. That means that the truck would be here and it would just fall, okay? Because it would make a 90-degree angle with the ground. So this force, what do you think would happen? The force would be the entire weight of the car. So the force when theta equals 90 degrees would be W. So the force would equal the weight of the car. Now, if you wanted to do that mathematically, we could. Okay, so here, F would equal W times sine theta. So the force would equal W times 0. So 0 pounds. For the second one, the force would equal the weight of the car times sine of 90. So the force would equal the weight of the car. Sine of 90 is 1. So the force is equal to the weight of the car. And again, that makes sense because gravity would be all of this force. Okay, and in this case, there would be gravity and it wouldn't be applying any force because there's no hill. Go ahead and do the next 3 problems and then pause the video and come check your answers. Be careful on number 3 that you're answering it correctly, meaning that they're not asking you for force on number 3. All right, so for number 1, we're going to have 5,500 times sine of 3.9. So this is going to be 374.08 to the nearest 10 pounds. So 370 pounds rounded. This is the grade resistance. For the second one, they want us to calculate F. 2,800. This one's going downhill. So that gives us negative 234.29. So the force, or the grade resistance, is negative 230 pounds. For the last one, the force, actually, let me just go ahead to a 2,400 pound car, so that goes here. That's the weight of the car. Is traveling uphill. The grade resistance is 288 pounds. Remember, force and grade resistance are the same thing. So since there are only 3 variables, what is the angle? We have to find theta. Remember, this is sine theta, so this is your only variable. So in order to solve this, I'm going to go ahead and divide both sides by 2400. Now, you can divide this, or if you wanted to, you could just leave it as a fraction. This does divide nice and evenly. It divides to 0.12. So my answer is not 0.12. That's not the angle. Remember, we just finished solving for angles up here. And when you're trying to find theta, which is an angle, you have to use inverse. So that's what we're going to do. We have to do the inverse sine of both sides in order to get theta by itself. You cannot divide by sine, just so you know, by itself, ever. So we're going to do the inverse sine. When you do the inverse sine, sine and inverse sine cancel, and you get theta, and then this ends up being 6.9 degrees. When you get an angle, it's never going to be very much more than 10, if at all, ever 10. When you ever drive up a hill, it's not really, they can't make it super steep, just so you know. So that's it for section 2.3.